Hi everyone, it's Kyle. So today we're going to be going over the chapter 1 to 3 test. And the purpose of this is to go over any questions you might have, either you're absent or you still have questions about the test, but we didn't have enough time to go over because chemistry is kind of a fast-paced class. And also, if you want to figure out maybe how to approach some of these problems in like the time pushing manner, and this is just the way that I'm doing it, and there's a lot of ways to do it. But hopefully just give you another perspective so that when the solution stoichiometry test comes around, then you guys are already ready and you guys are doing an awesome job. So I'm going to be recording using a calculator and periodic table and just a test, nothing else. I won't use any help sheets or anything like that. And also make sure to remember one more thing that chemistry is more than just numbers or equations. It's a lens to approach life. And so I'm going to be taking this lens over here and putting it onto my computer. And so you guys will be able to see my, I should be able to see, there we go, a timer calculator for our table. And also the work that I will be doing, which is going to be okay. So time starts now. Under 25 minutes. So I'll be explaining each step. So we have a substance, we have carbon, hydrogen, and oxygen. Oxygen. Okay, so we have some mass. Okay, so the most important thing is we understand this is a combustion analysis. Combustion analysis always has CXHY. So I'm going to be running kind of fast because this is like a temperature test. It might be a liquid or a gas. Plus O2 gas, an unknown amount, yielding CO2 gas, H2O, H2O liquid, there we go. And so I'm going to organize the mass under, so I have 12.34 for tetranoion. I have H2O 10.36 and 36.5 CO2. Great. I'm trying to find the mass of hydrogen in tetranoion. So the problem is I have HY. HY, I don't know how many moles of H I have on the left side. But remember conservation of mass, I have H on the right side. And so this mass over here and this mass over here, they're going to be the same. So I can say 10.36 grams of H2O liquid. Oh, sorry, not the notation, sorry. Times the mass over molar mass. So this is 18.0158 approximately grams per mole. Remember, mass over molar mass equals mole. I just memorized that. You need the calculator for that because this is, a really quick step that you need to do. And this is 1 mole of what, H2O. And you also have 1 mole of H2O. Only 2 moles of H. And again, you want to find mass in grams. So again, 1 mole of H. So just 9 grams. Oops, there we go. So boom, boom, boom. All these things are canceling out. So I just plug this into my calculator, 10.36 over the molar mass, which is 18.0158 times 2 times 1.0079. And my answer equals 46, which is 1.159 grams of H. Cool. So the next question, moles of O2 that reacted during combustion. Okay, moles of O2. Well, we know how much O there is here, and O2 is unknown mass. And so what we can do is, again, conservation of mass. Mass on the right is going to equal to mass on the left. So we can say mass of products mass reactants equal to, so we can say the same thing is equal to mass of O2 plus the mass of tetranoion, just like that. So then we know at this point that it's going to be 36.15 grams because this is the mass of CO2 plus the mass of H2O equal to the mass of O2 plus the mass of tetranoion. Again, this is a really conservation of mass heavy question plus H2O. And so, sorry, let's go back real quick. 6.15 10.6 equals O2 plus 12.34 grams. And then I'm just going to solve using some basic algebra. And I can use the calculator, 1.5 6 minus 4. There we go. Equals 34.17. And so the mass of O2, but remember it's looking for moles, so we'll have to divide this. So this is grams of O2 by the molar mass, which is 32, because it's 2 2 moles of O2, 32.00 grams of O2 of the mole mass equals 6, 7, 8. So 6, 8. Let's go with that. There we go. Okay. Empirical formula. Oh, okay. Empirical formula. That's a good one. We know the mass of hydrogen and the mass of oxygen. 154. Look at the mass. So mass of hydrogen we got. Mass of carbon. Oh, okay. So here's what we need here. Mass of oxygen is the hard part in this question. We don't know what the mass of oxygen is. The mass of carbon we can find just because of this right here. So what we're going to do is set up an equation. Mass of carbon is the mass of oxygen is the mass of hydrogen. So it's equal to the mass of hydrogen. This is 12.34. And the mass of hydrogen, given our other equation, is 1.15. Mass of oxygen, this is going to be our unknown. It's going to be really hard to find this. That's what we're solving for. Mass of carbon, here's what we're solving for mass of carbon. We know that the mass of carbon on the right is going to be equal to the mass of carbon on the left. So we have 36.15 grams of CO2. And we're finding the mass of carbon. So we need to find the molar mass. And the molar mass is 44.011 grams per mole. And again, this is just because memorize this from the periodic table over here. Times 1 mole CO2, 1 mole C, and we're going to go for mass. It's going to be 1 mole C is equal to 1 gram to C. Let's plug C to our calculator. Moles cancel out. Moles CO2 cancel out. Oh, sorry, moles of this cancel out. Grams cancel out. 6.15. Whole thing divided by 6. There we go. 6 grams of C. Now 1, 2, 3. Again, just do some algebra, and we get 12.34 minus in parentheses 1.159 plus 6. And again, this is a little bit messy because this is a time pressure test. Lots of stuff going on. Empirical formula. Let's break this down into our 4 main steps. Remember that we have percent, grams, go for the moles, and then we get the ratios. In this case, percent is not an existent step, so we just go straight to grams. For grams, well, we already got that. We'll do, it's going to be C, so C first, which is going to be 9.66 grams of C for every 1. O. Linked for moles, so we just convert this to moles, so times mass over molar mass equals moles divided by equals, how many moles? 9.66 divided by 12. 2. Yep. 2 moles. Again, sorry. Units are very, very important. Times yeah, by approximately. We divide everything by 0.02 because that is the least molar mass. 2. Note this is going to be 1. This is off by 10. And this is the tricky one. Divided by 0.02. 14. Next. So then now we have our equation. C10 H14. Oh, there we go. That's our equation. This is a molecular formula question based on the molar mass. So here's what we're going to do. we take our multiplication factors equal to the mass, sorry, not the mass. Yes, the molar mass of molecular over molar mass of empirical. So we know that the molar mass is going to be 348 grams per mole, given by the equation right there. And then we can find this one real quick. 12.011 times 10 plus 1.0079 times 14 plus O, which is 16, 150.2206 grams per mole. This is going to be a mental step. I'm going to say that N is equal to 2 just because it's 150 and 100. And so now I take C10, H14, O1, multiplied by 2 by 2 by 2. And so I get C20, H14, H28, O2. That's the answer. Cool. Let's go to the next one. Photosynthesis is the process by which plants and other organisms convert light into chemical energy. Okay, so we know the products are going in there. And so what are the reaction is divided by CO2, gas, plus O2, gas, yield. This is a chunk of it. Plus O2 gas, right? And it's collected. So we have CO2 from before. CO2 was 36.15, 10.36. 36.15 grams. Okay, that looks about right. And so now we can organize all of this stuff, write a balanced equation. Okay, find your chemistry is all about finding your significant other. C and C, those are the only ones that are each other, just perfect for each other. Only C. H12, 6. 6 times 2, 12. 6, 18. This has 6, so I should have 6 over here. Let's make sure this balances out. 6, 12, 12 for hydrogen, 12, 8, 6 plus 12, 6 plus 12, 18, 6 plus 12, perfect. This is our balanced equation. And write an ICF. ICF, draw the line because this is addition. And write the complete ICF table underneath. We're going to go for moles, so we're just going to go over. And so I'm just going to plug this into the calculator, divide by 44.01. And I'm going to get 0.8213 moles of CO2 divided by 18.08. 6 divided by 18.0158. 0.5750 moles. And now remember that in the initial, this is how much just given by the words collected used for the photosynthesis reaction for the product section, right? At the initial, we'll have none of this, and that's why it'll be set to 0. Minus 6x, minus 6x, plus x, plus 6x. And so now we need to figure out what the limiting reactant. Oh, wait, okay, limiting reactant. Okay, so actually, it's already asking us what the LR is. Remember, the lower LR is defined by the lowest mole over coefficient ratio. Okay, so we're going to find the LR of this real quick. And so how we're going to do this is we're going to take the moles, carbon dioxide, so lower the coefficient, which is 6, set up an inequality, and we need to specify what this is, which is gas, and then take the other one, which is 10.6. I'm sorry, that's not right. We need to put moles, molar coefficient. So moles of H2O over 6. Now, let's check it out. 6 and 6. Normally you'd plug this into a calculator, but I can do mental step. This is going to be less than because it's 0.5, 0.8. And so, therefore, LR is going to be equal to H2O because it has the lowest mole over coefficient, which, because this is the LR, set this 0, and then we set up an algebraic expression. 0.5750 6x 0 plus 6x on both sides. And I'm going to just plug this into my calculator, like the chug. 0.750. Okay, so now that we know this, then we can just go ahead and literally fucking chug for everything else here. It's going to be helpful to find out what 6x is. 6x is going to be equal to 6.575. Yeah. And so I'm going to subtract this 0. So I'm going to store this as 6x. 0.8213 minus 0.575. Also use the store calculator function if you want. I just chose not to do that. 14.6 moles. This is x and this is 0.0. Just leave it here. Moles. And then we also have that's right. And so there we go. We have our completed ICF table right there. And now let's go into our next question. Mass in grams of all substances left. Oh, perfect. So you can see that how many questions we have left. And 9 minutes. Okay. You can see that over here, all the substances left once the reaction is completed. Everything is going to be left except for this LR, except for H2R. So really what they're asking, the question's asking for is mass of mass of 6 H2R, 6 mass of 2. To get this, well, we take the moles, and moles times molar mass equals moles. So we're going to start off with moles of CO2, which is 0.262463. Yes. We're going to multiply this by molar mass, which is, oops, there. Stop, check, times 44.01 mass. Yeah, they're asking for grams. 10.4 grams CO2 oxidants equals mass 0.953 of 6 times the molar mass. Ooh, molar mass is going to be a chunky boy. 14.011. Sorry, wait, 12.011 times 6 plus 1.079 plus 6. Enter. 1.16. 6 over 1 mole. Again, don't let the physical limit of the paper limit your mental capabilities. Something so we used to say. And so I'm just going to zoom in here and make some more space. And so here I will get 0.983 times 0.864 equals 172.65. I think we have 4 6 so I'm going to this. 7 grams. The last one equal to 0.575. So 75 moles times 16.00. Oh, wait, that's definitely wrong. So it's 32 grams. So for that to 0.575 times 2 2 is going to equal to 18. Ooh, so glucose is equal to 6. Oh, it's a second question. Second yield is going to equal to actual yield over theoretical. Set actual yield. Well, it's right here. So that's a theoretical yield. Grams. And then actual is given here. 15, 5, 7 grams. Oh shoot. Go on. Here. Let's mess up some of them. That's 6 plus 12. 9, 16, 6. 72. Seven equals 0.075. Okay, that's definitely not right. Something like 7. It's off right now. Okay, I know I'm off by 10 somewhere. And this is where my 4 minutes extra come into play. I'm going to pause this and then I'll resume the extra 4 minutes. Oh, okay, so it seems that I made a 10% mistake. I just checked my work over here. I know that the yield is coming from here. And so what I did was I said, okay, this mass can only be messed up if this molar reactant's messed up. So I took 10.36 divided by molar mass 18 and got 0.57 divided by 6 again, 0.093, 0.093 over here. Oh, bam, messed up. There should be actually 0 over here. So, and so I can just go ahead and move the decimal over here. So, totally okay to make mistakes. Just try your best to catch them. And so felt a little bit off as well. So again here, 2, is that right? 12.72, 17.27, 17.27, and this is a little bit right. 27.785%, so times 100, and the answer is 78.57%. Minute and 35 seconds left. So yeah, that was the whole test in 25 minutes. It's a little bit messy because it's a time pressure test. So sometimes it will be a little bit messy, especially when I'm writing on not a piece of paper. But the whole essence of this is really just to see how fast you can analyze the problem and apply what you already know. I hope that this was helpful for you guys. And if you have any other questions, we'll be here during 6th period during class. If there's anything else that you would like to see in future videos, maybe, or also just in class, please let us know, and we'll be happy to make future videos for you guys as well, in addition to specific lectures that you guys want during 6th period. So we hope that you guys are having a good rest of the day, and this is off with 40 seconds. Great, and happy doing chemistry.